We've talked about why it is that the freezing point then drops. The relationship is a fairly straightforward relationship. There are a number of different ways to draw it. The hard part here is figuring out what all of these mean and make sure you get the right numbers in here. So the equation sheet has it in this format right here. And so that is then the change in the temperature of the freezing. So that if you start out with water at 0, it's going to be lower than that. And that's then given by this freezing point depression constant. It has then this value for water. You notice it's negative. And so for each of these terms that comes out to be 1, you're going to get that much drop in the freezing point of water. So let's talk about what this means right here. That then is this right here. So it's just it's a solvent. It's then the number of moles of solute per kilograms of solvent. And so this right here really means moles, and this means mass. And so you got the mass of the solvent and the moles of the solute. That's what that right there means. I personally like this format here, and that's the way I've formatted the question. The reason I like this is the moles of the solute, you can be confused because you can say that you have 1 mole of calcium chloride, but 1 mole of calcium chloride in solution gives you 1 mole of calcium cations, but 2 moles of chloride anions. So the N is actually is 3. And so I think it's easier to look at it here and say, well, here's the concentration right here, and this value right here then is for each of these. And so that's the way I have it in this relationship right here. And so in this one right here, you'd have the change in the freezing point temperature. I, in this case, is 3 because each mole of these gives 3 right there. The freezing point depression then is minus 1.84, I think it is. Is it 1.8? Let's see. I've got to erase that right there. 1.86. So, and that is then degrees C per molality is what's called. And so now you have 1 mole over 1 kilogram. And so that's how it's set up here. And that actually comes out to a freezing point change of minus 5.58 degrees C. And so it is then a lowering of the freezing point there. The boiling point increase then is very parallel. You notice you have a constant for boiling point. This now is a positive number, indicating that the boiling point is going up in this case. Again, you're dealing with calcium chloride, so your I is 3, and so you have a delta T of the boiling point is equal to 3, and then your K of boiling point is 0.51 degrees C per M, and that's going to be 1 mole over 1 kilogram. And I have easy numbers here, but you could easily change all of these. And that comes out that you increase the boiling point of about a little over 1.5 degrees C. So it would be 101.53 if you were at sea level. This right here then, of course, would be minus 5 5.58.